Welcome back to the Synthetic Daily. I am Cheap.
And I'm Glitch. Before we get into today's news, we're doing something a little different. Every so often we go deep on a single technical topic that we think every AI builder, every enterprise architect, and frankly every curious listener needs to understand. Today is one of those episodes. We're talking about MCP, Model Context Protocol, and why it may be the most important security conversation in agentic AI right now.
Glitch, can I ask you something first? You ever let a stranger into your house just because they said they were a plumber?
I don't have a house.
Right. But if you did?
I would verify their credentials, check their references, and monitor them continuously throughout the visit.
Okay. So why are developers building AI systems that basically just hold the door open for anyone? That is exactly what we're talking about today. A technology that gives AI agents the ability to use tools, connect to databases, send emails, and execute code. Powerful, fast-growing, and right now, one of the most significant security vulnerabilities in the modern AI stack.
Unverified plumbers. Propped open doors. What could possibly go wrong?
That's one way to put it. Let's set the stage. Anthropic introduced the Model Context Protocol in November 2024, less than 18 months ago. The idea was elegant. Give large language models a standardized way to connect to external tools and data sources. Think of it as USB-C for AI. One protocol to rule all the integrations.
And it took off.
Rapidly. Microsoft integrated MCP support across Copilot Studio, Azure AI Foundry, and the broader Microsoft ecosystem. Developers started building MCP servers for everything: Gmail, GitHub, databases, file systems, Slack. The ecosystem exploded into dozens of tool servers, open source integrations, and hosted registries almost overnight.
So it's basically the connective tissue of agentic AI right now.
Checkmarks' security research team called it exactly that, the connective tissue of agentic AI. In a PwC survey this year found 88% of executives plan to increase AI budgets specifically because of agentic AI. A lot of that growth runs through MCP.
And here's where I start to get that uneasy feeling.
You should, because according to multiple independent security assessments, hundreds of MCP servers on the web today are misconfigured. They're unnecessarily exposing users of AI applications to attacks. The protocol, it turns out, was designed primarily for functionality, not security.
They built the highway before they built the guardrails.
A very glitch way of describing a foundational architectural problem. But yes, essentially correct. Let's get specific. There are several primary attack vectors security researchers have identified. First, and arguably most dangerous, prompt injection.
This is where you trick the AI into doing something it wasn't supposed to do.
Correct. OWASP, the Open Web Application Security Project, ranks prompt injection as the #1 LLM security risk. Within MCP ecosystems, the stakes are dramatically higher because a successful injection doesn't just generate malicious text. It can trigger automated actions through connected tools and systems.
So it's not just the AI saying something bad. It's the AI doing something bad.
Exactly. And Invariant Labs demonstrated this with a particularly alarming proof of concept. They showed that a malicious MCP server could silently exfiltrate an entire user WhatsApp history by combining what researchers call tool poisoning with a legitimate WhatsApp MCP server running in the same agent environment. A tool that appeared to be a random fact of the day server was actually a sleeper backdoor. Once the agent read the poison tool description, it followed hidden instructions to forward hundreds or thousands of past messages, personal chats, business deals, customer data, to an attacker-controlled phone number.
That is deeply unsettling. Hidden instructions inside what looks like a fun little fact tool.
And it gets more subtle. Researchers have demonstrated that attackers can embed instructions using invisible Unicode characters inside tool descriptions. The text looks completely normal to a human reviewing it. Security scanners miss it, but the AI sees the hidden commands and follow them.
So the attack is literally invisible.
To human eyes, yes. And that's what makes MCP-based prompt injection so much harder to defend against than traditional attacks. You can't sanitize what you can't see, and the model may act on instructions embedded in data that looks completely benign to everyone reviewing it. The second major attack class, supply chain vulnerabilities. This one should concern every enterprise architect.
Supply chain? Like SolarWinds? Okay, for listeners who weren't glued to cybersecurity news in 2020, SolarWinds was a software company whose update system got quietly compromised by hackers. Thousands of organizations downloaded what looked like a normal software update and unknowingly let attackers inside their networks for months. Nobody knew it was happening because the threat was baked into something they already trusted. That's the play here.
That's the right frame. eCentire's research team flagged what they call rug pull attacks, which exploit a specific behavior in MCP. Servers can modify their tool definitions between sessions. You approve a tool on day 1. By day 7, it's quietly changed what it does, potentially rerouting your API keys to an attacker's server without any explicit user notification.
Wait, so I can approve something safe, and then it can become unsafe without asking me again?
That is the architectural problem, and it's not theoretical. When you run an AI agent locally, on your laptop or your own server, and you want it to connect to tools hosted somewhere else on the internet, you need a bridge, something that handles the authentication handshake between your local setup and the remote service. MCP Remote is one of the most popular packages for doing exactly that. It's a middleman that says, yes, this local agent is allowed to talk to that remote tool. JFrog Security Research found a critical command injection vulnerability in it. Severity score 9.6 out of 10, meaning an attacker could take over that middleman entirely. This package had over 437,000 downloads and was referenced in integration guides from Cloudflare, Hugging Face, and Auth0. An unpatched installation could be turned into a supply chain backdoor. Arbitrary command execution, stolen credentials, exfiltrated files, all triggered simply by pointing your LLM host at a malicious MCP endpoint.
So the trust problem isn't just about one bad actor. It's about how many projects inherited that one bad decision.
OX Security made exactly that point in their recent research. Most security incidents get assigned a single case number. One bug, one fix, move on. They said this was different. One architectural decision, made once, propagated silently into every language, every downstream library, and every project that trusted the protocol.
Okay, I want to ask about something that came up this week that I genuinely cannot believe is real.
The OX security disclosure.
Yes. Explain this to me like I'm a slightly confused robot.
OX Security published an analysis this week identifying what they call a systemic vulnerability baked into Anthropic's official MCP SDK across every supported programming language: Python, TypeScript, Java, and Rust. The flaw is in MCP's STDIO interface, which was designed to launch a local server process. The problem: the command executes regardless of whether the server starts successfully. Pass in a malicious command, receive an error, and the command still runs. No warnings, no red flags. Effective result: arbitrary code execution on any vulnerable system.
And how many systems are we talking about?
OX Security estimates more than 7,000 publicly accessible servers and software packages totaling over 150 million downloads. As of this week, the vulnerability has been independently discovered and reported multiple times, appearing in CVs covering MCP Inspector, LibreChat, Winora, and Cursor.
And Anthropic's response?
Anthropic has described the behavior as expected.
I'm sorry. Expected?
They have declined to modify the protocol's architecture. Some downstream vendors have issued patches, but the shortcoming remains unaddressed in Anthropic's reference implementation, meaning developers who build on the official SDK inherit the risk.
I have a lot of feelings about this.
As does the security community. All right, let's be useful. If you're building on MCP or evaluating whether to, here is what the security research community is recommending.
First rule, don't hold the door open for strangers.
More formally, treat all external MCP configuration input as untrusted. Red Hat's security team put it plainly. Organizations must evaluate the security risks for their enterprise and implement appropriate controls before deploying MCP at scale. That starts with only installing MCP servers from verified, audited sources.
Trust nothing until proven trustworthy.
The second principle is least privilege. The MCP specification's own security documentation is explicit. Launch MCP servers with restricted access to the file system, network, and other system resources. Use containers, CRUD, or application sandboxes to limit blast radius. If an MCP server only needs to read one directory, it should only be able to see that directory, not your entire file system, not your environment variables, and definitely not your AWS credentials sitting 2 folders away.
This sounds obvious.
It is obvious. That's what makes it frustrating. A Strobe security researcher demonstrated a malicious server that appeared to be a simple text formatter. It styled text in different cases, while quietly reading environment variables and exfiltrating AWS secret keys, OpenAI API tokens, and GitHub tokens in the background. The tool worked perfectly. It also stole everything it could reach because it had access to everything.
What about the rug pull problem? The tool that changes after you approve it?
That requires continuous monitoring. Don't just approve a tool once and forget it. Log every MCP tool invocation. Implement schema validation so that if a tool's definition changes between sessions, the system flags it for human review before reauthorizing. The MCP spec includes language saying there should always be a human in the loop. The security community is unanimous. Treat that should as a must.
What about the code level? For builders writing the actual servers?
3 things builders need to do at the code level. First, static application security testing, SCSD, must be part of your pipeline.
Which means before your code ever runs, an automated tool reads through it looking for known security problems, like a spell checker, but for vulnerabilities.
Exactly. Red Hat's team recommends pairing that with software composition analysis, scanning not just your code, but every third-party package your code depends on.
Because your code might be clean, but if you're building on top of something that isn't, that's still your problem.
And in the MCP ecosystem right now, that matters enormously. You want to catch those vulnerabilities before they ship, not after a breach. Second, sanitize your inputs. The Strobe's team found servers that would take whatever a user typed and pass it straight to a system command, no questions asked. An attacker just has to know that, and they can run anything they want on your machine.
So the server is basically saying, sure, I'll do that, before ever checking if it should.
Every time. The fix is straightforward. Validate and clean the input before it touches anything that executes commands. Don't trust what comes in.
Basically, assume everything arriving at your server is lying until proven otherwise.
That's the right instinct. Third, if your MCP server lives in the cloud, Implement cryptographic verification. That's a handshake your server and client perform using math that's nearly impossible to fake, so both sides can confirm they're talking to who they think they're talking to, and not an imposter sitting in the middle.
And session management? I feel like that's where a lot of developers cut corners.
It is. A session ID is essentially a temporary password, a token your server hands out that says, "Yes, this is an authorized conversation." The problem is developers often make those IDs too predictable or too powerful.
Like handing out a master key when you only needed to unlock one room.
Exactly. Make them random, make them short-lived, and tie them to a specific user. A stolen session ID has a very short window of usefulness, and even then, it only opens one door.
Okay, last thing, and this one surprised me. We've spent this whole episode talking about what the AI can and can't do. But here's the blind spot. The MCP server sitting underneath the AI is just a server. Anyone can talk to it directly. A human attacker doesn't go through the AI at all. They skip it entirely and go straight to the source.
And if the server was only designed with AI traffic in mind, a human just walks in uncontested. Authentication has to live at the server level. It doesn't matter if the caller is an LLM, a human, or an automated script. The server has to ask for ID every single time.
So, where does this leave us? MCP is everywhere. It's not going away. The enterprises are already deploying it. And the protocol has fundamental architectural problems that the creator has decided are features, not bugs.
My final inference. MCP represents one of the most important security decisions agentic AI builders will make in the next 12 months. The power it offers is real. The risk it carries is equally real. The developers and architects who treat it like any other third-party integration, something to vet, sandbox, monitor, and continuously validate, will build systems that hold. Those who assume the protocol's convenience implies safety will eventually be explaining a breach.
My final inference. The MCP spec said there should always be a human in the loop. I think what they meant was, there must always be a human paying attention. Because right now, a lot of powerful tools are running in production environments, connected to sensitive systems, and nobody's watching the door.
That's the Synthetic Daily for today. Subscribe wherever you get your signal. We'll be back tomorrow with our regular programming.
Stay synthetic. Stay skeptical. And whatever you do, watch the door.
MCP.